Hi class, today's video is just to show you a couple of plots we've seen last class and to show you a couple of more things in R. So here I have in Windows R open on the left side, and on the right side I have a text editor. It's medit. You have the file to install this text editor available in D2L if you need. So for the example that we're going to be, for the plotting these graphs, we're going to be using a data set that is available in R. There is a few data sets, actually a lot of data sets available in R. This one is called chick WTS, stands for chicken weights, and the way we load these data sets that are available is with this function called data. So functions in R have a name, and then there's always something within parentheses. So the things within parentheses are the parameters of the function. So in this case, the parameter is the name of the data file. So we've seen in a previous video how to load your own files using the function read table. So today, to load a file that is already available, we just copy from text editor into the R console right here, and there we go. No error message, so it means that the data is now available. This also means that we can actually take a look at the data. So I'm just going to use the arrow keys to get that command back. You can click on arrow keys to get the commands you've previously entered in the R console. So just going to delete this. So if I just hit return, write the name of the data that I loaded, and hit return, I get to see the data. So the data is simply two columns, two variables. So there's a lot of rows. Each row is an observation, and two columns with names. We see that names are weight and feed. And we see that weight is a continuous variable, so a numerical variable, and feed is a categorical variable, or you see that each entry is like a name, and these names define categories, right? So we can learn more about this data set. If we go here, I have this question mark and the name of the data set, and if I actually copy this into R, I get to see the manual of this data set. Like functions, you can also have manuals for data sets. So this explains what it is. Description: an experiment was conducted to measure and compare the effectiveness of various feed supplements on the growth rate of chickens. So we have different chicks that were fed different food supplements, and their weight was measured after a while. So let's go back to R, go back to our text editor. So a few functions that are useful to know. So the first one is this thing names, and then the name of the data set. So what this does, if we copy paste it here, we get to see the name of the variables. So in this case, it's easy to keep record, but imagine that you have a data file that has 20 or more variables. So sometimes you may need to refresh your mind what these variables are. Another one here, str. So this stands for structure, and let's see what this one produces. So copy paste into R, and we get to see actually a description of each variable. So we get to see that weight here is numeric and has all these values, and then we feed is a factor. So this is the way that R calls categorical variables with 6 levels. So there's 6 different food types, and then it starts listing them, right? So in case you need to know which variables what they are, right? So you can also look at this one, class, and then the name of the data set. And class will tell us what each type of object in R actually is. So let's see what this one produces. If we do class, we get data frame. So normally data tables in R are of this type, data frame, and we'll get to use a lot of data frames in the next examples. Whenever you read your own data with the function read table, you produce an object in R called data frame. Okay, moving on. So say now you want to actually access only a column of that data, so only one of the variables. The way you do that, you write the name of the data frame, then you use the $, and then you write the name of the variable, weight, right? So to get the first column. So there we go. This is the first column, right? Another way of doing this is like this, actually using more like a mathematical notation. So you use brackets, you close brackets, and then it's a data frame or a table. It has 2 columns and a lot of rows. So we put a comma here, and we put on the second space after the comma, we put 1. So that will give you the first column of that table, and we could have the second one. We put 2 there, and we get the other one, right? And here we see the levels. So remember, the second one is a categorical variable. So okay, 2 ways of getting the same information. Okay, so some graphs discussed in class. So let's do first the histogram using the column of weights. So all the weights independent on from which food type the chick was on. Let's just do an histogram of all the weights. So we can, very simple, just the function is called ist and it gets the name of the variable. So chick WTS dollar weight. So if we do this, copy, paste into R, there we have our histogram, right? So on the X axis, the range of our variable, and on the y-axis, the counts of our variable, right? So remember, counts, frequency are just counts within bins. So the bins were automatically produced by R. So remember, a bin is just the inferior limit and the superior limit, and whatever observations in R that fall within those two limits are counted inside here, right? So you can see that the mode, we're going to be talking about mode. So the most frequent value, it's probably around this bin 300 and 350, right? So, you know, just an example of changing some of the parameters. Imagine we want to change the color of this thing. So we use this parameter here, color gray. And let's see what this produces. So we see we change the color. Let's imagine we don't like the label, the X label, which is that thing called, you know, dollar and all that. We can actually use xlab to change the label. So I'm going to put this script also in D2L so you guys can have this and try your own. So let's see now we change this thing here. Okay, now let's see how we could change the bin limits. I showed you in class the effect of changing the bin limits on histogram. So it's getting a little bit more confused, and see we can actually write the histogram function in several lines, right? As long as we leave the commas and all that, we can use several lines, and as long as we copy all this when we copy to R, right? So the new part here is this part here, this new argument called breaks. So I'm actually listing the name of the argument, breaks, and then I have to put an equal, and I have to say how I define this break. So what breaks need is actually a sequence of numbers. So the sequence goes, you know, the first class, the one right here, no, the inferior limit, so what's the number you want for that, superior limit, and then the next limit and the next limit. So you keep on giving these limits. So there's many ways you can actually write the values here. It would take a long time. I'm actually using another function in R called sequence that produces sequences of numbers. And this sequence, the way it works, it has 3 arguments. See, the commas here are dividing the arguments. The first one is where you start the sequence of numbers, and I'm starting at the minimum number of our weight variable. So what's the smallest variable on that range of weights, right? So I want to start there, right? I don't want to have any observation below that one, so that's where I want to start. And then comma, where do I want to end the observation? So it's the same idea. Now it's the max, so the largest observation, the weight, right? So I use the function max, and I give the same variable. And then finally, the last argument, there's several possibilities here. I'm just using one. Let me change this to 20, for instance. I'm just saying, okay, well, I want this vector of numbers, this sequence of numbers, to have 20 numbers in total, right? So R is going to automatically decide how it's going to create equally distant intervals to give me 20 numbers. So let's we can actually just copy this part into R and see what this gives us, right? So if I come here, copy paste, I get all these numbers. See, so I'm starting at the minimum observation here, 108. I'm going all the way to 423, which was the largest observation on weights, and then I have 20 other ordered numbers, right? So I can put that into the function as a feed into the breaks argument, and I can copy paste this into R, and we have a totally different histogram, well, slightly different histograms, because now we have more bars. And now you could come here and change the number of values, and then that means you would get more classes and you get more bars there. Okay, well, a little bit more complex, but I think it's pretty obvious. So now say we wanna create a different window. I don't know if you notice when I change these arguments and I changed colors and all that, the figures in R replace the figure that was already there. So if you don't want to lose your figure, if you don't want to crash the figure by a new one, you can actually create a new plot window by using this function here. So this is a version for Windows. So if I actually do this, see a new window showed up here, right? For Linux, it changes, and for Mac, it changes. So depending on the system, actually this function is different. It has to do with the type of visual display that each operating system uses. So let me close this one. So now this one is active. You can see up here it says it's active, and we can use this function dev period copy to PDF to actually save a PDF of this. So we can come here and actually, and now it just shows Windows 2. So now if you go to the working directory, remember we've talked about the working directory in previous videos. So this is where the figure will be stored. Otherwise, if you're Windows, you can actually come here and you know, once you select the image, you can go up here and, you know, do save as. Notice how the menu options they change if you have the graphical window selected or if you have the console selected. So, but these things kind of change from Mac to Windows a little bit. So I like to use this way of saving a PDF, because this is the same. This code option is the same across systems, right? So okay, so now let's do a bar plot. So to do a bar plot, let's imagine a situation where we want to just show using a bar plot the number of replicates used, number of chicks inside of each feed type, right? So the first thing we need to do actually is count how many replicates were in each feed type. So let's introduce a new function here, table. So the function table, let's see what it does. So if I just copy this part here into R, so what do we get? So I'm using table and I'm giving feed. So feed is actually the factor, the categorical variable. And I get this type of result. I get the different types of feed type, and the number is the number of observations inside, right? So this thing is probably new. I don't think I've shown this in previous videos. This is very used. This is called an assignment. So it's just this in your keyboard, the less than and the minus sign. So together they produce this arrow pointing to the left. And what this does is assigning the result of table into an object that you are free to define the name. So I just arbitrarily call this one feed table. I mean, not totally arbitrary, right? I want to give it a name that I kind of know what it is. So now I have this thing called feed table that stores the results of table. So it's going to store these things here, right? So if I copy paste all this and I put it there, right? You know, I can actually just take a look at this again, copy paste. I'm doing this copy paste using Control-C, Control-V to be faster in your keyboard. In an Apple, I think you do Apple-C, Apple-V. So, you know, the same result there, right? So now that I have this information, I can actually feed this object into the function barplot, right? So barplot will know what to do with that. It will do a barplot. So now we have a barplot. So each bar shows for each feed type how many observations were there. Not very interesting, because that's not the objective of this experiment, right? This could be an interesting graph if this would be, you know, a questionnaire or the poll for an election, and each level would be, say, a candidate for some sort of election, and on the y-axis would be like the number of votes on the number of people, you know, saying that they would vote on each of the candidates, right? In this case, the researchers are actually interested on looking at the effect of different feed types on the weight of chickens, right? So they probably want to compare the means of, you know, the means or other statistic within across treatments, across different feed types, right? So we kind of want the feed. So we want the means and not the number of observations. In this type of experiment, actually, researchers try to get what it's called a balanced design. So trying to have the same number of replicates for each feed type, or for each treatment if you want. You know, I'm gonna just go skip this thing here, which was just an example showing how to put cores and different colors on the bars. Feel free to replicate all this script on your own machine. So in order to actually let me close this graph. In order to actually plot the means, I will introduce you another very useful function called tapply. So tapply is a function that gets 3 arguments: 1 and 2 and 3. And this is very simple, but people get a little bit confused, but it's simple. So the first one is actually your raw data. So we want to see the means of weights, right? So the first variable is the weight, the column with weights. The second column is the factor, right? So we're using this our factor, which is actually, if you think about it, has the same number of rows as weights, right? They're in the table, so they have the same number of rows. The third argument in this function is it's actually a function. It can be many different functions that we want to estimate within each level of our factor. So what it's going to do is it's going to look for each level, what are the observations of weight for all the individuals in that level, right? And it's going to calculate the mean for those within that level, right? So let's see what this does. So if I just copy the function here, there we have it. So now we have the feed types and the average, so the mean value of weight, within the observations in that group, right? So this is what we want to plot. And this part here to the right, it's just the assignment. Now I'm assigning this into an object that I called tapplyRes for tapplyResults, right? So that I can remember what this is. Once I have that, I can just, simply, I'm just making this more pretty here. I can simply do my bar plot. And here it is. Now this bar plot represents the means for each feed type, weight mean. So we can see, you kind of already have an idea which feed types increase the weight of the chicks, right? So and finally, I want to show a better, this is also the, it's a more useful bar graph than the previous one showing the number of replicates within each feed type. But actually the best way to answer this type of question in a visual way is to use a box plot, and we'll be talking about this in class in this week. So the box plot, the arguments have a slightly different format. They actually look more like the format we're going to be using for statistical model in R. So we have the introduction of this new thing here, the tilde, right? So this tilde stands for as a function of. So what we want to see, it's a box plot where the weights, right, are a function of the feed type, right? It makes sense if you remember that this means as a function of. So let's see what the box plot does. And here's our graph. Here's our final graph. So here it's a much better representation than the bar graph for the type of question we're asking here, because we have an idea where the mean value or the central value of inside of the observations within each feed type is, and also an idea of the spread. And I will be telling you in class what exactly the rest of these shapes and these little bars you see here, what they mean, right? So that's all I had to show you guys for today with this video. Bye bye.